And next up, we have James Masters presenting Building Powerful Applications with Open Access Extensions.
Okay, thanks, Marshall.
Sure.
Okay, so as an agenda for today, today's discussion on my topic, first I'm going to go into open access extensions. I'll kind of back up a little bit for everybody just to align all participants on what OA extensions are and why they're important. I'll give a review of past and current extensions. And then there have been several presentations that I've given over the years with respect to extensions, and I thought I would just kind of collect a few of those to have a nice tour of some of the types of applications that could be developed using extensions. And then I'll very briefly touch on how you can create your own extensions using OA AppDefs. And then at the end, I will put out a little call for participation. We definitely benefit with more participation that we have. So we'll talk about that at the end. Okay, so to start off, what is the ESG? It stands for Extensions Steering Group. And extensions that go under this group are essentially contain layered functionality on top of the open access standard. And so you can think of this in a way of solving problems that are common to many individuals within the industry. So we can get together, discuss those common problems, and to bring up a quote that we've used in the past, we write one time and write the code one time, and then you can use it many times as a community shared library. And so that essentially equals collective development and shared deployment. And in a way, it creates this kind of industry standardization. Quick note on this. I know that based on my work with other extensions and the different thoughts that people put into it and considerations, everybody's bringing their experience and carefully thinking through possible outcomes. And so these extensions are often built it slows things down a little bit, but it makes them formal. And when you brand these extensions as being formally released under an industry umbrella, as opposed to a proprietary or in-house solution, it usually gets the attention of other individuals because it, again, takes that time and care. Okay, so why are extensions important here? So basically, open access is quite stable. It's been out for several decades. It's been used effectively. It works very well, and we really don't want to adjust that too much. And so one way to address this kind of these two needs where you need to have additional capability, but you don't want to disturb something that's stable is to have these extensions. And so that allows for some dynamic growth, and that growth happens without having to touch the standard, and it's layered on top. And so, in addition to that, the extensions do also promote additional open access usage, encourages development of even more extensions. And so that works together to build an ecosystem. And I'll share a little bit more on that in the next slide. Okay, so this is kind of a list of past and current extensions, and I will upfront apologize if I've missed any here. These are the ones that I've been involved with, and I believe is pretty comprehensive. If not, it's pretty close. So if anything was missed, it was my own fault, and I apologize for that ahead of time. The initial few extensions that came out, the first two rows here on the table, were OA script and OAXPOP. And OA script is really, really important because it provides an interface to open access without having to write C++ code. I think Rob mentioned in his presentation that it enables this rapid prototyping type of capability. So the three current languages supported are Python, Ruby, and Tcl. There were other languages in the past, Perl and C# that were used, that aren't currently active. On top of that, we have OAX POP, which is a high speed layer Boolean resizing library, and we recently added some connectivity extraction features to it. And I'll just stop there briefly on those two. Between those two, there have been literally hundreds of end user applications that leverage these extensions. We use them here quite often. Again, I'll show some examples of that in subsequent slides here. But I know that others are also using these. And then below that, we have other extensions that have started within the past few years. The track pattern one hasn't been used in a while, but was discussed for a time. And then we have three new extensions, read and write multi-patterning color information in open access, which Ben will speak about soon in today's meeting. And then the translator working group, which will be discussed as well today, which converts open access to other formats such as JSON. And then we have a domain-specific language kind of shell to navigate. I did want to point out there are some footnotes here with a 1 and 2. Those are using OA script and OAX POP. So you can see how these extensions are not only used in end applications, but other extensions can also leverage them and add even more capability. Okay, so this was a screenshot of how OAX POP worked with the Open Access API. And I put this in here just to illustrate the layering approach. So on the far left side, we have the Open Access API. That stands as it is. And then we have these extensions in the middle. And in this case, both OA script and OAX POP can work together, which provides scripting access into the Open Access API. And then on the right-hand side, there's a third-party library in the industry, in the Boost library, that is being used for the engine for the Polygon operations. So you can see these different entities can come together to build these extensions. The next two slides are just, again, these were presented in prior years. It's been quite a while. I just wanted to highlight them again just to show for those who haven't seen them yet. But we've developed several applications. These are a couple that we shared before. The first one is a density calculator. This application was written in OA script. It uses OAX POP, and it had some layer of connectivity to a third-party layout editor. And what happened was the layout was exported real-time from the editor, brought into OA script and OX POP. It was processed with high speed. You can see some metrics on the right-hand side there. There was a few layers of hierarchy in this case, across 19 layers, about a little more than 250,000 shapes, and then the runtime was about 1 second to calculate the density real time. So this application, again, could connect to multiple different interfaces and was standalone. Similar to the other one, this was the same thing. It's a standalone application connecting to a layout editor, and this performed methodology checks where we would check that the design was compliant to certain design TFM requirements. And so you can kind of see some code snippets on the right-hand side. Some of those layer operations were very simple expressions that allowed us to do these kinds of checks with very little code. The other thing I wanted to highlight, this is a new addition to OAX POP. There was another aspect of the library that was not initially put in, that we later put in, which is the ability to extract connectivity. We did get that put into place a couple years back, and this was a slide that showed some results from that using the NAND gate standard cell contribution that was made to SI2. where we, as you can see here, the layers were loaded in, and based on the connectivity extraction routines, we're able to highlight, in this case, an internal net and then the ground here. So this is really exciting to me because this is not a very easy problem to solve necessarily. It's definitely solvable, but to get it done with high speed and other accuracy and so forth, it does take a lot of time. And we were able to leverage that library and make it available. And this is another example of that library. Again, these are past screenshots that we've shared, where in this case, the size of the database, of course, is much larger. It's not a standard cell anymore. And you can kind of see some extracted nets that were pulled out of there. This one took about a minute or so, and most of it was loading the database. But once the database was loaded, the extract time was less than a minute for quite a few shapes here, as you can see, about 3.7 million. And then one more quick one, sample application using this extractor. We basically put together, once again, from that NAND gate standard cell library, the ability to create a layout netlist. This would be an example of how you could feed something in to LVS, layout versus schematic comparison. And this was done with, in this example, it was done with Python code, which is about 335 lines of code that included spaces and comments. So it wasn't very complicated for what it did, a pretty complicated function, but the amount of code and the entry point to get in there wasn't too difficult. So, okay, and then finally, to kind of bring in something new, I was asked to maybe share a little bit about how you could create your own extensions using OA app defs. So the OpenAccess API has an app-def object type, and that allows end users to create application-specific ways to store data on OpenAccess database objects directly. And so you can essentially create your own, you can extend the object types to have payloads that are there. Those payloads can exist persistently, meaning that they would be saved to disk and read back from disk, or you can have it in memory only if you just needed something for the session. There's various data types supported. They're listed on the right-hand side there. That's a screenshot from the OpenAccess API. And then I just kind of put together a very simple Python hello world type of script that shows how these could be used. The first step in that blue box is to create a string app def. This is essentially registering an app def of a given data type, in this case a string, and that app def is being registered to have the ability to attach to an OA shape. Okay, and the name of that app def is my str, my string. So that first line of code essentially registers the app def, and this is the syntax that's used in Python. It's actually different by language because each language has different idiomatic ways of doing this. But anyway, Python's pretty well used, and so I've used that here. The last 4 lines of code are kind of hiding something. There actually was a shape that was pulled out of the database that's not shown here for brevity, but presupposing that we have an OA shape in a variable called shape, it shows here how we can basically get out of that shape and using that registered app def, the resulting string value that was stored on the shape. And so, of course, the first time we do it, there's nothing there. And so the default is an empty string. That's shown by that print statement there, that first empty string in the print statement. And then we go ahead and set on the shape a value for that app def. I just put the word foo in there. And then I ask again to get that back out, and it prints now that data has been stored on there. So this is just a basic example. It's definitely a big topic that's not going to fit into a presentation in a forum like this, but just to kind of show you that you can save your own data on the open access database directly. And just a quick note, again, we're definitely not going to go any deeper than this because of how complicated it is, but I'm more than happy to share examples that there have been prior examples contributed, and I can also help as well, or others can help if there are questions and interested to use these. But just a note that when you take these app defs and bring them together, you can actually create very complicated data structures and even new object types in the open access database. One example that will be again presented later today is the OX color extension, which uses app defs. And so that's an example of that. And then we can also have multi-attribute objects. So I just showed how you can store a string. You could have other data types and other attribute names to store. And when you use them all together, you can create more complicated objects. There is also a byte array, the ability to store a sequence of bytes, and that essentially allows you to store any ASCII or binary type of data. I mean, you could put documents or images or sound files or whatever on your open access database. Not that you would want to, but just to kind of give an extreme example of how flexible it is. You can do all of those things. So this is the last slide. I did want to put out a call for participation. Once again, we have 3 very active and newer extensions that are going through a lot of development work. We'd love to have your inputs there. And then I did also want to emphasize that a lot of times we think the bar is very, very high to create a new extension, and I want to get rid of that myth. It definitely does take, you do have to, there's a formal process where you do have to submit some paperwork. Basically, there is a vote and you have to submit the proposal with some justification and so forth. It's not a very long document, but there is a process. But other than that, it really doesn't need to be more complicated than that, and it doesn't have to be a very well thought out idea. It could be refined within the working group. So I did want to make sure that that door is open and nobody is discouraged. Okay, and I think that concludes my presentation.
Questions? You got 2 minutes.
Oh, hi there. I have a question. Thank you for your presentation. Earlier on in your presentation, you showed some applications that did things like measured density and so on. Right, so like slide 6 and 7.
Correct.
Are those separate standalone applications, or are they applications that run with the in-memory database of an EDA tool, for example?
Yeah, that's a really good question. They are completely standalone. These were written in Python. They used Qt for the GUI, Python wrapping for Qt for the GUI. And let me just say that it depends on the application as to whether or not you can directly bring it in from memory or you have to go through disk. I will say in this particular case, we went through disk, but there has been proven, there has been a presentation by Synopsys some time ago in an SI2 forum. There was a demo about, I don't know, 8 years or so ago, maybe 10 years ago, where they presented the ability to do it in memory. I don't know if that's still the case or not, but it was presented in an SI2 forum. So I was going to mention that here as a direct example, but it just depends.
This is Jeff Brubaker at Synopsys. I can confirm we're still doing that. OA script ships with our custom design tools.
Oh, cool.
Okay. Yep. So it just depends on how flexible it is for the platform that you're using as to answer to your question.
Right. Okay. Thank you.
All right. Well, thank you, James. I think it's time to move on. We are right on schedule.